And so where were we? We're back on the video now, and we're going on with method 2. Oh, my pointer's gone. Method 2. So this is when you reduce an amine with a reduction of nitriles, rather, sorry, and to produce amines. And so a nitrile is just an RCN group, so it's a alkyl group with a cyanide attached to it. That's what a nitrile is. And so again, nucleophilic substitution with cyanide. I'm not going to go over it because you've done it. You should have done it before. If you react to haloalkane with a cyanide ion, the nucleophilic substitution. So this is just an example of a haloalkane RBr, the bromine there. Will form a nitrile because the cyanide will replace the bromine. Form a nitrile. That's a nitrile. One thing to remember about this reaction, very important. Remember aqueous ethanol. This reaction is done in aqueous ethanol. You need to write a note somewhere and just remember that this reaction is performed in aqueous ethanol. Okay. And so moving on to the next step in the reaction, what you want to do is, this is a nitrile, but it's not exactly an amine yet. And so you perform catalytic hydrogenation of the nitrile. And so this is a reduction reaction, and it's hydrogen. It's when you react the nitrile with hydrogen in a nickel catalyst. Remember, nickel catalyst in this second step here. There's two steps in this one, and nickel catalyst in the second step. You react the nitrile with hydrogen, and it will undergo hydrogenation. Okay, and so you will form RCH2NH2. It's because the carbons will accept hydrogens, and so will nitrogens. And so you form an amine here because you see the NH2 group. That's an amine. Okay, so that's not too much to understand there. Catalytic hydrogenation of a nitrile. You got a nickel base, a nickel catalyst here. React the nitrile with hydrogen to form the amine. And this step one is actually, I'm not going to say actually. Remember both these steps, both very important. This one perhaps more so, but remember this step. This is how you form the nitrile in the first place, and you will need to know that. Moving on to the last step, the last method. So, just as a side note, this is much better than the method 1 we went over, because only primary amines are formed in this one. So you can get a much more pure product. You're not forming different like tertiary amines and all these other amines that all here, there, and everywhere. Okay. And method three, kind of I put there because you're not making alkyl group amines anymore. This is making a phenylamine, so it's still an amine, but it's a different kind, you know. And so this comes in two steps. I've two slides. This one is step 1. You've got a benzene, this is benzene, as we mentioned just before. We'll go with more in aromatic chemistry, but benzene is reacted in a mixture of, very important to remember this, concentrated nitric and concentrated sulfuric acid. Sulfuric spelt the right way. I'm going to get a lot of hate for that, but concentrated nitric and concentrated sulfuric acid. Okay, remember that. And it will produce a nitrobenzene. So this is the step 1. So we haven't made an amine, but it makes a nitrobenzene. That might be new to a lot of you. Nitrobenzene. It's just got an NO2 group attached to the benzene. Okay, so this reacts with the HNO2, O3 rather, the nitric acid, concentrated nitric acid, remember, and a mixture of sulfuric acid in there as well to form nitrobenzene and water. Moving on to step 2. Okay, if you do want to know any more detail on how these reactions occur, I won't go into it in this video, and you can if you're really that interested, I can make a video on them, but you don't need to know. I say you don't need to know, but in that much detail. But I will actually recommend you to ChemNet, where you can ask those kind of questions and they'll answer them in very good detail. ChemNet, that's a good forum for chemistry. But anyway, step 2, National Chemistry Society is what it is. So nitrobenzene is reduced to phenylamine, which is the product we're looking for, phenylamine, the amine, when tin and hydrochloric acid with tin and hydrochloric acid reducing it. I'm not going to read this how it is. So basically, you've got your nitrobenzene from the last reaction, and you have to react it with hydrogen. The way you get the hydrogen is from the tin and hydrochloric acid, because the tin reacts with the hydrochloric acid and makes tin chloride, I believe, so you're left with the hydrogen. And so this hydrogen will react with the nitrobenzene and replace the oxygens. So it will the hydrogen will reduce the nitrobenzene and replace the oxygens to form the phenylamine, which is the amine that we're looking for. And the oxygens will just react with some more hydrogen to make water. But one thing to note about this is the last slide, by the way, so thank God there's one more slide, but it's a bit more interesting. Is that this entire reaction is done within hydrochloric acid, and as you know, hydrochloric acid, what's going to happen is, because this is a base, it will take in another hydrogen, as we went over at the very beginning of this video, of the last video actually. Because the phenylamine is a base, the lone pair on here will form a covalent bond with the hydrogen that's floating around, the proton, and so it will form a salt with the chloride as well, because phenylamine, when it reacts with hydrochloric acid, forms a quaternary ammonium salt. And so the way to get out of this, which you went over again, so I'm not going to cover in too much detail, is when you have to react it with a strong base, such as a sodium hydroxide, and this will again, went over this, so I'm not going to go into too much detail, and this will reform it back into the phenylamine, which we're looking for, okay, forming water and sodium chloride in the process. But just as a footnote, just a reminder to remember that you have to react it with a strong base. If you ever see this reacting with HCl, it's going to form a salt, because this is a base, remember that. And last slide now, some economic importance of amines, and we're done on amines, thank God. I say thank God, it's been fun. It's been fun. And so examples of what you can do with amines is that amines are used in the production of nylon, polyurethane, dyes and drugs, a whole host of things. They're very, very important in industry. Quaternary ammonium compounds are used in things like conditioners. So remember, this is a quaternary ammonium compound. This little squiggly line here is just a representation of a hydrocarbon chain. And one thing to remember about this hydrocarbon chain is that it'll be hydrophobic. It's hydrophobic. Like, again, you don't need to know this in so much detail, but it's hydrophobic because the carbon and hydrogens have very similar electronegativity, and so they're non-polar, and so they will be actually they'll be repelled by water. Hydrophobic means that it doesn't mix with water. It's like it's repelled by water almost, because the water molecules are quite quite negatively charged, and so they'll repel them. But whereas when it's in this quaternary ammonium compound, so this bit here, the hydrocarbon chain, that's hydrophobic, whilst this is a cation because it's got a nitrogen here and ammonium, kind of. And so it'll have a positive charge because the nitrogen's got 4 bonds to it. And so it's very useful in some things like hair conditioners, where your hair picks up negative charges throughout the day. This is why you need conditioners. You don't need them, but the cations will attract them towards the surface. So this positive cation here will attract the negative charges towards the surface and form a coating, preventing static build-up. So they'll like coat your hair. So they'll stay on your hair, and it prevents more further static build-up in your hair, keeping your hair and your fabric, because it's same concept for fabric, soft, and it prevents flyaway hair. Which, if you don't know what that is, I didn't. It's like, frizzy hair basically. So yeah, but thing is, with the economic importance of amines, just always remember that it'll probably want you to mention the hydrocarbon chain here because it's hydrophobic, and the fact that it's a cation, and they'll usually, it's quite self-explanatory. As long as you remember those 2 facts, you'll be able to figure it out really, if there's any other questions on that. But if I haven't covered anything in enough detail in this video, do say in the comments and I'll try and get back to you, or I'll try and do it. If it's that bad, I'll do another video on it or something, or I'll redo the video. But thanks for watching, and hopefully I've helped you. Okay, well, goodbye.